Hi, and welcome to part 3 of the LumenPnP calibration series with OpenPnP. If you're watching this video, you should have already finished your preliminary calibration. If you haven't gone through that process, check out this video right here. This video is about tweaking your calibration by populating your first board, the FTP. This board has a bunch of placements on it that's used specifically to test your calibration and make any adjustments necessary before you dive into your first production board. This board comes with every LumenPnP and is also available on our GitHub page. By the end of this video, your LumenPnP will be placing accurately, and you will have gone through the process of setting up an entire job from scratch in OpenPnP. This video is meant to be auxiliary to our written docs page. Please make sure that you're following along with our docs page at docs.opula.io, as the docs page is always the most up-to-date source of information. All right, let's get started. The very first thing we're going to do is mount the board fixture hardware onto the LumenPnP staging plate. And this is going to hold the FTP board in place while population happens. Every machine comes with a kit of this hardware and can be mounted on the staging plates to accommodate essentially any size and shape PCB. There are 3 main parts. The first is the static board mount. This is purely acting as a rigid edge or corner for your board to index into. There's the dynamic board mount, which has a flexible aspect to it. This is what actually holds your board in place. And then a board support, which is just a little spacer that pops into a hole in the staging plate to provide a little bit of Z support for your board. This is the configuration we recommend for the FTP board. Your staging plate has coordinates of letters for the rows and numbers for the columns. Our docs page has these coordinates listed out, and you can also reference this image here to see where you should mount them. I recommend first putting your static board mount at a 45-degree angle, and then loosely tightening in your dynamic board mounts. The little lip on top of the flexure on the dynamic board mount is meant to give you an indication of where the edge of the board should sit that would put it under good tension once you've actually locked it in place. Try mounting your FTP and make sure that it is snug and rigid in place and it's not going to move around at all during population. That's good. After you have the positions tuned well, you can add the board support. Before we mount our board for population, we're actually going to apply a little bit of double-sided tape onto our FTP. Double-sided tape is a fantastic tool for testing placements before committing to pasting up a board. There is a roll of double-sided tape included with every LumenPnP, so look in your tool bag and grab your spool of tape. And apply 4 strips of double-sided tape in between the 2 white lines on your FTP board. After you place down each strip, I recommend just tapping it with your finger a little bit to make sure it's actually adhered to the board well. It does not take a lot of adhesive strength to hold a component onto the board, so even if you lose a little bit of stickiness, it's fine and they last for a good number of cycles. Once you have your 4 strips on, you can use the included X-Acto knife in your toolkit to cut off the excess on the edges. When you're done, your board should look like this. Now you can go ahead and mount it on your mounting fixtures. The next thing we're going to do is actually set up the board in OpenPnP. Before we do anything else, we're going to download the position file from the GitHub repo. The position file is what you export from your ECAD software that OpenPnP uses to figure out where to place all the components on your board. So first we're going to go to the LumenPnP releases page, and from the most recent release, we're going to download the ftp-top.pos or position file. And now in OpenPnP, I'm actually going to go to my boards tab. I'm going to click the plus, and I'm going to say create new board. I'm going to make a new board. I'm just going to call it ftp.board.xml. Now, it's really important you do this in the Boards tab. In the Boards tab, with the FTP board that you just made selected, go to File, Import Placements, and then select KiCad.pos. If you were importing your own board, you would use whatever export your ECAD supports here in OpenPnP. But we're going to do KiCad.pos. I'm going to select this file that I just downloaded here. And I don't have a bottom file, there's just a top file for this board. And I'm going to make sure that assign parts and create missing parts are both checked under my options. All this means is that OpenPnP is going to make all of the parts it doesn't already recognize in your position file automatically for you, and it saves quite a bit of time, so I highly recommend checking these 2 boxes. And then you can go ahead and hit import. So it doesn't immediately look like anything happens, but if you go back to the job tab, click plus, select existing board, and then select the board that you just made. Now you can see it's selected in this row, and all of these locations here are different placements that the board has. So the FTP has a lot of placements. It actually has 40 diodes, 40 LEDs, and 40 resistors. OpenPnP is immediately giving us an error here about a missing feeder, but that's okay for now. We're going to address that in the next section. The first thing we want to do is tell OpenPnP where our FTP board is. So the first thing I'm going to do is home my machine. Find our homing fiducial, and then do nozzle tip runout calibration. Now we are going to find the bottom left-hand corner of the FTP board with our top camera. This FTP board has an origin point of the bottom left of the board, but depending on your origin point in your different ECAD software, this might be a different location. Definitely reference our written docs about how to identify the actual location of your board. It does depend on where your origin happens to be in your design software, so it can be a little confusing figuring out how to tell OpenPnP where it is, but there are straightforward ways of doing it. So what I'm going to do now is just jog my camera over to the FTP, All right, so here we go. Now I can see it. So I'm going to jog over to the bottom left corner. There we go. So this is my origin point of the board. It does not have to be perfectly exact. It just needs to be roughly correct. This is also a great opportunity to make sure that your board is pretty squarely mounted in the machine. A little bit of skew is totally fine, but try and generally make it as perpendicular as you can to the camera. So now what I'm going to do is in this top row, I'm going to capture my camera position where it is right here, making sure that my board is actually selected in this table. And what that's going to do is it's going to save my camera position into these coordinates. So I'm going to click this here, and you can see it just added in X and Y coordinates for the origin of this board. A very quick way to check and see if I was even remotely close is to click on some of my placements down here in this table and to jog the camera to those and see if it's kind of close. I'm going to start by jogging to the fiducials on the board. Just like how the LumenPnP has a homing fiducial that lets it find out where its home position is, PCBs being populated with a pick and place should all have fiducials so the camera can identify exactly where the board is in space. So the FTP has 3 FIDs, FID 1, FID 2, FID 3, so I'm going to select FID 1 here, and I'm actually going to tell OpenPnP that these actually are fiducials. So I'm going to go under the type category, and from placement, I'm going to select fiducial for these 3. So I'm going to click FID 1 here, I'm going to select it in this table, and I'm going to jog the camera to the placement's position, and we'll see how close it is. All right, that's pretty good. It is off by a little bit, but that's exactly what fiducial calibration is for. It does not have to be perfect. A handy feature in OpenPnP is this button right next door, which will jog the camera to the next position in the table, which is really handy if you want to just jog through the position of every single part on your board. So here's our FID 2, also very close, and FID 3 also pretty close. So our position is pretty darn good here. Our origin is set. The last thing that we need to set is our Z position for the board. This is a super important number because it tells OpenPnP where it should be placing your parts. If you set this number too high, your parts will actually fall off the tip a little bit and you'll have a slightly scattered placement. And you don't want to go too low because then you'll be pushing really hard on the head into the board. You want to set this position just by having your nozzle tip just barely touch the surface of the board and set that position. So that's what we're going to do right now. I'm going to jog the head of my machine just so it's somewhere on top of the board, and I'm going to select the N1 nozzle, doesn't really matter which one, and I'm going to bring it down so it's just about touching the board slowly. Beautiful, and there it's just barely touching. And if I look down here in my bottom right, I can see my Z is actually 4.5 millimeters. So that's what I'm going to put in for my board height here. This green section down at the bottom is your DRO, or your digital readout, so you can see where your machine is at any time if it's green in the background. So I'm going to put in 4.5 because that's my current Z position. Now we're ready to check and see if fiducial scanning works for this board. The easiest way to do this is just select the board in your board list, and then click on this button here, which is just going to perform a fiducial check. The fiducial check uses the top camera to find those fiducials, just like it does with a homing fiducial. So if you have fiducial homing working well, you shouldn't really have to worry about tuning this at all. But if you do run into trouble here, we do have an entirely separate video about tuning your vision pipeline, linked here and in the description. All right, so here it is, finding the fiducials. It does it a couple times just to make sure it's really accurate. And there we go, all 3 fiducials found. So now I can jog to my fiducials again, and pop around and see that they're all perfectly centered. And if I go to my parts, I can also see that they're perfectly centered on my parts here. Every single one is dead on in the center of the placement. This is exactly what we want to see. This is a sign of a good fiducial scan. After your fiducial check is successful, you can check this little check FIDs checkbox next to the board. And all this does is make sure that when you run a job, it will always check fiducials first when you run the job. In this next section, we're going to mount and set up a LumenPnP feeder, which we'll be using for populating the FTP. I have a feeder right here, and I'm going to mount this on my machine at slot 19. There we go. The footprints on the FTP are 0603 components, but you can still use the board to test 0402 or 0805 components as well. I'm going to be using some of the included 0603 components that come with the Getting Started kit, and I'm going to mount this into my feeder right now. If you need help on feeder setup, we have an entirely separate video about loading tape into your feeder, which you can check out here, and a link in the description. After you have your tape loaded, press the forward feed button a handful of times. This pulls the tape taut on the indexing wheel, and make sure that when you set your feeder position, it's going to be accurate. To set this up in OpenPnP, I'm going to go to my feeders tab. I'm going to click the plus, and there's a whole bunch of different feeder options here. There are 3 main ones that we recommend using. The first one is the reference strip feeder. One of these was actually included in your Getting Started kit. It's just a little 3D print that also mounts to your staging plate, and it just holds the tape there available for the nozzle to pick. This is a really cool feeder type because it can actually find the holes in your tape, automatically detect them, and use that to make sure picking up is very accurate. If you have a bunch of strip feeders mounted on your staging plate, this is the one I recommend if you have white tape. The hole detection does not work quite as well with black tape and clear tape. The next is the tray feeder. Tray feeders are good for if you have a tray of components or if you have a strip feeder that it's not possible to find the hole detection. A tray feeder can be configured so it just picks in a row or in a grid, so it's a pretty handy backup, even if it's a little bit more manual. The last one is the photon feeder. Photon is the name of the firmware and protocol that the LumenPnP feeders communicate over. We're going to add one of these so that we can scan and find our feeder. So I'm going to hit accept here, and now I have one unconfigured photon feeder. Now there aren't any actual photon feeders loaded in here, so I just have a menu for scanning and looking on the bus to see if I can find any. So I'm going to say search here, and you can see the maximum address to scan is 50 because that's how many slots are on the LumenPnP. So I'm going to go ahead and hit search, and now it's going to scan, and I will find that little green one right there is the one that I have mounted to the rail. And if I just add a tray feeder to pop away, and here it is, sure enough, in slot 19. This number here is actually the UUID of the feeder. It's its unique identifier. It knows what slot it's in automatically, and there's information like what part is in it and what part pitch we should feed for the part, and some location information. The first thing that we're going to do is we're going to jog the head over to the pick position for the feeder. So I'm just going to manually jog the head over to the feeder, and I can see here in the view, here's the tape coming out of the feeder. So I'm going to jog down, and here are my parts in the feeder. I want to pick the part that is just barely visible outside of the pick window. So I don't want to select this one, which has already been out and exposed for a while. I want to pick the one that was just revealed by the film. If you feel like it's a little too close to the edge, you can always press the forward feed button on the feeder to move it forward 2 millimeters. That gave me just a little bit more space. I think I like that placement better. And now I'm going to go jog and center the machine in the center of the void in the tape, not the center of the part. The parts can move around quite a bit inside the void. So you want to make sure that you set your pick position in the center of the rectangle in the tape, not the component. So I'm going to capture my camera position right here for the slot location, and I'm also going to do the same for the part offset. This field is for a feature we're working on but isn't fully implemented yet, and right now it's easiest to just keep this all set as 0, and it will automatically capture just the offsets in here. So you can just click the camera capture button twice and it'll stay exactly like it should be. Next, we need to grab the Z position. Now I'm going to jog the appropriate nozzle for the part that I want to pick, which in this case, because it's a pretty small part, I'm going to choose my N045 nozzle tip on my N1, my left nozzle. I'm going to jog it broadly over the top of this part. And I need to make sure, of course, that I have my N1 selected when I want to start jogging down in Z. And when I'm starting to get close, I'm actually going to turn on the pump. The reason that we do this is because when the pump is on, air is rushing into the nozzle, so as we jog it down closer and closer, we can see the position that the part will actually hop up to the nozzle tip at, and we want to set it about 200 microns beneath that height, just to make sure we have a really consistent pick. So I'm going to turn on my VAC1 under the Actuators tab, and then I'm going to keep jogging N1 down until I watch the part pop up. I'm going to bring it down another 200 microns, and then I'm going to save that Z position. Here we go. Oh, there it went. I just saw it pop up to the nozzle tip. So I'm going to go down 200 more microns. 1, 2, and then whatever position I'm at here, you can see this is 4.1 millimeters in the Z. That's what I'm going to put in for my Z height. 4.1. Now I can go into my actuators, back to VAC1, and turn it off. Part should fall back in, and then I'm going to jog the head up and out of the way. Now make sure you hit apply on the feeder so you save these positions. And lastly, we need to select the actual part that's in here. This is an 0603 resistor, so that's exactly what I'm going to choose. If I look down at the bottom here, this part is the part that OpenPnP made automatically for me when I imported the position file. So this is what I'm going to select and hit apply to save it. And our part pitch is 4 millimeters. There's a part every 4 millimeters, not every 2 like with 0402 and some other smaller parts. And if I click the feed button, it will feed forward 4 millimeters. Before we can actually pick it though, we need to tell OpenPnP that this part that we just assigned to the feeder is pickable by an N045 nozzle tip. The way we're going to do this is going into packages, which is different than parts. For example, 0805 is a package, it's a certain size, but you can have a 10K or a 1K resistor in that same package. Different parts, same package. So under packages, I'm going to select the one that's assigned to this part. And then underneath nozzle tips, I'm going to check compatible for N045. And this is just telling OpenPnP that that nozzle tip can pick that part. The other thing we need to do before we can actually pick this part is set the height of the part so OpenPnP knows how to move the Z-axis to place it. The way we do this is going into the Parts tab, selecting the part, which is resistor 0603, and then under height, enter the height of the part. In this case, we'll put 0.5 millimeter, so 0.5. 0.5, there we go. And now we can go into feeders and try and pick a part. And there we go, now we have a part on the nozzle tip. Now what we're going to do is we are going to check our part identification pipeline with bottom vision. This is when OpenPnP looks at the part with the bottom camera, figures out where it is, and aligns it correctly. The way that we can do this very easily is just going to the Parts tab and select the part we have on our nozzle tip currently, go to the bottom vision settings tab, and then just down here there is a test alignment button. This will just go through the bottom camera calibration procedure for this part. So let's give it a try. So we can see here the part was found very quickly, and we had a red rectangle that appeared over the part. This means OpenPnP was able to find the part without an issue, and you can see it even placed it perfectly in the center of the camera view after it did that vision cal, so it knew exactly how to move it to get it centered. This is exactly what we want to see. If you find that your red rectangle is actually stretching really big outside of where the part actually is, there's some tuning you need to do with either your exposure or your vision pipelines. There's an entirely separate video about going through that exact process, linked up here and in the description. But this looks great. What I'm going to do now is discard this part because I don't actually need it. So I'm going to go to Special and then Discard. And the LumenPnP will go and just discard the part. I'm going to test feeding and doing vision a couple more times just to make sure. Looks good. Great, this feeder is looking good and we're ready to use it. So in the feeders tab, we can click enabled here. And once we do that, we can go back to our job tab and see that all of our resistors now say ready. Now I only set up resistors, and for this test, I don't want to try and populate all of the diodes. So I'm actually going to disable these parts. What disabling does is it still keeps that information in the board and in the job, but you're just telling OpenPnP, I want you to ignore this part right now. This is a very easy way to disable and enable a part on job. So I'm just going to select all of my diodes here. I'm going to shift click to select all of them and then right click. There's a whole bunch of things you can do in bulk in OpenPnP when you have parts selected. So I can change all of them to fiducials. I can move them to the top or bottom. I can say that they're actually already placed or not, disable them, and set the error handling. For enabled, I'm just going to set them to disabled for this demo. So all we have enabled now is our fiducials and all of the resistors. Okay, with our board set up, our calibration done, and our feeder mounted, we are ready to try and run a test job. This is done in OpenPnP by pressing the big green play button at the top. A really nice feature about OpenPnP is you can pause it at any point and step through just bit by bit through a job to watch as it goes without having it just careen through every single instruction. It can be really nice to do if you're working on debugging something or tweaking some values as you go. But we're just going to hit play and see where it places some parts. So first thing, it goes and it finds the fiducials. Looks like a good detection there. Same with FID 3 and with FID 1. We feed on the feeder. Go pick up the part, check it under vision, it looks good, and then place it down on the board. Excellent. I'm going to let this run for just a few parts and then we'll take a look at what we get. All right, so I'm going to pause it right here. I've just placed 4 parts, and I'm going to take a look and see how well it's done. OpenPnP is great about letting you just pause the job at any point, move the head around, do other operations. It still knows where it is in the job and its progress, but it lets you just kind of stop everything and do calibrations and tweak things in the middle of a job. So I'm going to just jog the head out of the way, again, still in the middle of a job, and I can take a look at my board here. All right, so this looks pretty close, but I do have a little bit of a translation up and to the right. I can show you in the OpenPnP view as well. So we can see under placed, R1 is a placed resistor, so I can just jog the camera to this and we can see how accurate it is. So we can see that R1 is actually shifted a little bit to the right and up. And if I go to the next one, R2 is also shifted to the right and up. Same with R3 and same with R4. So to me what this says is that we need to change our top camera to nozzle tip offset just a little bit. We just need to tweak it down and to the left just a bit, and then everything should be placing just fine. On our docs page, we also have a full visual guide for doing all of these calibrations. If you notice that some parts only on some nozzles are placed differently, there's a global offset, there's a part orientation based offset. Whatever you're seeing on these first few parts on the FTP, we have them all up on the website. So if you've noticed that your parts are placing a little bit shifted, I highly recommend you go check out the docs page. There's a link in the description, and just click on the image that looks most like your board, and we give you steps going through and resetting whatever calibration needs to be adjusted. So for this one, I think it's my top camera to nozzle tip offset. So I'm going to adjust these values just a little bit. So what I'm going to do is I'm actually going to jog my camera to my fiducial here and make sure that it's still centered. It absolutely is because we did our fiducial cal. But what I'm going to do is I'm actually going to jog my nozzle tip to the fiducial position and see if it lands perfectly on it. And sure enough, it actually lands just a little bit up and to the right of the fiducial, which is exactly what we're seeing with our placements. This confirms that it is a top camera to nozzle tip calibration. So the solve here is to just go in and update your top camera to nozzle tip offset. I'm just going to use the wizard for the fiducial on the board here. So I'm just going to jog until it's centered directly on that fiducial. And that looks great. So I am going to store that position. I'm going to jog my head back up. And I'm going to find it with my camera. There we go. Dead on. And I'm going to calculate my offset, and I should see a little change here in these values. Sure enough, I saw a little change. So I'm going to hit apply here. And now I can go back to my job. I can select a part that hasn't been placed yet. And I can now go check and see R8, unpopulated. My camera's perfectly in the center. Now I'm going to move my nozzle tip to that position and make sure I select the correct nozzle tip here before I do this and see if that's centered. And that looks much better. I'm going to jog my head back up just a little bit, and then we can resume the job and see if that improved our placement. If you do change this in the middle of a job, it will automatically redo nozzle tip calibration, which is pretty cool. So if you hit play and you see this happen, that's why it's happening. And that is much better from R5. I could still tweak the value just a little bit, but this is much, much better than R4. All right, let's keep letting it run for a little bit. Much better. There we go. That's what I want. That is perfectly accurate placement there. I'm going to go ahead and let it run a few more parts and just make sure everything is running exactly like I expect it to. I'm also going to watch the vision pipeline as I go and make sure that it's always accurately hugging the component. The point of running this job is to make sure everything is running smoothly and calibrated well. So I'm going to keep my eyes peeled for anything not placing correctly or any vision not perfectly hugging the part. Here we go. All right, and the job is now done. If I go and I look, I'm very happy with that. That calibration is looking good, and I'm ready to set up my own job. Again, if you run into other calibration issues like parts being rotated incorrectly or only some parts being offset or any other placement error, I highly recommend checking out our docs page where we have a visual representation of all the different kinds of placement errors and instructions for fixing them. Also, please do not hesitate to reach out to us at our support form. There's a link in the description to that as well. We're ready to give you a hand and help you get up and running. If you're ready to dive into setting up your own job, there's a whole job setup tutorial video as well. You can watch that right here, also a link in the description. It's for actually populating a real product, and we walk through the whole process beginning to end.